In this video, we're going to explore contour diagrams and the relation to word problems or descriptions, verbal descriptions of functions. We're going to look at three variations here. In one function, we're going to have a function of two variables where h is the degree of pleasure that you get from a cup of coffee, and that's going to depend on two variables that we'll consider. There are many others, but two would include the temperature and y being the amount of coffee that was used to brew it, or something to do with the strength of the brew. Let's explore the other functions next, and then we'll be able to compare and contrast the features we would be looking for. Our second function is one described in words as the number of TV sets, so F is the number of TV sets sold, based on two pieces of information, one, X being the price per TV set, and Y being the amount of money spent weekly on advertising. If we know the price and the amount spent on advertising, we should be able to make some forecast about the number of TV sets sold. Last but not least, our g of xy is going to be the amount of gas per week sold at a gas station, where x is the amount spent on bonus gifts to customers to incentivize purchases, and y is the price charged by a nearby competitor. Let's take a look at the pictures, and then we'll be able to compare. We have three contour diagrams laid out here, and at first glance, especially without any units here, it's not at all clear what we would choose for one function or the other. That's where going back and looking for the patterns we expect to see in the contour diagram is going to be crucial. When we talk about the function h of xy, we can talk about individual relationships. In particular, if we talk about the relationship between temperature and enjoyment of a cup of coffee, it's not going to be a straightforward function. Everyone's going to have their preferred temperature that is lower than burning their mouth off, but still warm enough to be enjoyable. And around that temperature, there's going to be a maximum enjoyment. And as we get away from that temperature to either too hot, where it becomes scalding, or too cold, where it's just less enjoyable, less satisfying, we're going to see a local maximum for the function h. And we should expect to see the same thing with the amount of brew. There's going to be some sweet spot for each individual that's the perfect strength of the coffee, and it will have the same kind of profile. If we make it a little bit too strong, that's okay, but it's not as good as the optimal. Make it a little bit too weak, same thing, it's not as nice. And if we just go down to water, then we don't call it coffee anymore, and we would definitely have a drop off in the enjoyment at that end. And likewise, if it just becomes tar, we wouldn't enjoy that very much either. The challenge is then to tie those two graphs together into a contour diagram. And we can see out of these graphs here, there's only one that really describes having a local maximum for enjoyment, and that is this graph here. So if we were imagining the axes here as y, which was the amount of coffee in the brew, and on this axis we had temperature, we can see that there would be a sweet spot in this graph where if we go past that temperature, things start to go down. If we go with too much coffee, too little coffee, we're going to enjoy that cup of coffee less. And so this would be the match for our h of xy, or the enjoyment of the cup of coffee. Neither of the other two graphs have that local maximum structure in them. Well, does that make sense that the other two don't have that? Let's take a look at the actual words again and see what makes sense. We'll take a look at f of xy next. Here we're going to be looking for relationships again between x and f directly. What we know about finance and economics is that if x is the price per TV set, if we increase x, we're charging more per TV set, then we expect to sell fewer. Expect to sell fewer. And that would translate to a decrease in f of xy. So as we move towards larger x values on a graph, we would expect to see fewer values or a lower TV sales. However, if we look at the y value, if y is the amount of money spent on advertising, as we increase y, we expect to sell more TVs. That's in fact the purpose of advertising, along with other softer goals. Well, that would result in an increase in our function. That should give us enough information to nail down which of the two graphs we're talking about. So what we talked about is if we increase X, we should see a decrease in our sales. Notice what we have here. If we increase our X, we're going to go from 300 sales to 200. That matches. Compared to here, if we increase X in this scenario, we're going from 200 to 300 to 400 as our outcome values. That is going up, which does not match what we just talked about. So what we have in this scenario here captures our intuition better. This would be our f of xy, which is equal to the number of TVs sold, where X is then represented by the TV price, and the Y direction is the amount spent on advertising, on ads. And we can see no matter where we are, if we increase our sales, or rather if we increase our amount spent on advertising, we move up and we change contours from a lower number to a higher number, which represents more TVs sold. Opposite, anywhere we pick, if we increase our X, we're going to go from more TVs sold to less TVs sold or fewer TVs sold, because increasing the price cuts into demand and sales. Well, that leaves us with one last option to consider, and we just have to make sure that the graph that we described in words here actually matches the graph that we see. So here we have the amount spent on bonus gifts to customers, and there again, if we increase X, we would expect to see an increase in G. And likewise, if Y is the price charged by a nearby competitor, well, if their price goes up, we also expect to sell more gas because customers are going to come to us as well, or instead. And so in this scenario, we expect an increase in X to increase our sales, and an increase in Y to also increase our sales. And in fact, that is exactly what we see in this graph here. If we move to the right, our sales increase like 200 to 300 to 400. And if we keep X constant but increase Y, we see the same kind of increase. So X in this graph would nicely represent the bonus gifts. Y would represent the competitor's price. And the values inside the contours themselves, the labels on the contours, represent G of XY, which is the amount of gas sold. And there we go. So once again, we can get some good information about contour diagrams, this time describing a scenario pretty thoroughly, but based primarily on a word description or a verbal description of a scenario.